Okay, so today I will be showing you guys logarithmic equations, or graphing logarithmic equations to be specific. Okay, for this we are going to graph y equals 8 plus log 2 x plus 5. Okay, first we have to look at the base. Our base will be this 2. This is important because if our base is over 1, that means we have a logarithmic growth equation. And when our base is lower than 1, for example 0.25 or 1 over 4 or something like that, whenever it's under 1, that means it would be a logarithmic decay equation. And that's very important. Secondly, we look at this. Whenever something is positive 5, you should always know that it's left 5. And then this, which is positive 8, which is up 8. And we create a graph, okay. And for logarithmic equations, we always start at 1, 0 when we're graphing. Always start at 1, 0. Unless it's going to be a reflection against the y or x axis, then we would start at negative 1, 0. And this is our starting point. So then here we go left 5, 1, 0. Then here we would go left 5. So we'd go 1, 2, 3, 4, 5. Would be over here. Be at negative. Let me erase this. Would be at negative 4, 0. Negative 4, 0. Because 1, so negative 4, 0. Okay. Then we'd go up 8. So it would be right here at negative 4, 8. Okay, so this is where our graph is going to pass by. That is a transformational point. And for here we go to, now we have to find the vertical asymptote. So the vertical asymptote will be, it always starts right here, always starts right here. Always starts at the y-axis. Then we would go left 5. So we go over here and then left 5. And our vertical asymptote would be at y equals negative 5. Okay, so that we have there. And then we would have to draw the graph. The graph, logarithmic growth parent function graph always looks like this. This is the parent function for a logarithmic growth. It always goes like that. So that means we have a 2 right here as a base, so that means it's growth. So we would start from down here, go all the way up, and then turn right here to go this way. And the transformational point, would be, we would just look at our we would look at our thingy right here where we turn at, and it would be negative 4, 8. And that would be a transformational point. Our vertical asymptote would be at y equals negative 5. Our domain, we see that it doesn't go left anymore. It goes max negative 5, so I mean negative 5, and a positive all the way over to infinity, so positive infinity. And for our range, for logarithmic equations, the range will always be negative infinity, positive infinity. It will always be that. Okay, so that's our first equation. Now let me get to our second. Okay, our second equation will be y equals negative 7 plus log 1/3 x plus 3. Okay, that would be our second equation. For this equation, we have to look at this base, which is 1/3, which means it's a decay. That's important. Always look at the base. Make sure you know it. Okay, you don't see any reflections towards any axis, so we start at 1, 0. start at 1 0, and we see right here x plus 3, we go left 3, so 1 2 3, we would be right here at negative 2 0, and then we got to go down 7, we would go down here to negative 2 negative 7, and now we have to find our vertical asymptote. We go left 3, left 3 is right here, so y equals negative 3. Okay, now this is a decay equation. So for our decay equation, we have to, there's another parent function for it. But the parent function for the decay equation is, still goes through 1 0, but we come from the top and we go down like that, okay? And it'll be infinity that way. So for here, we would start at the top, but all the way down till we get to our transformational point, and then turn right here. So for this equation, our transformational point would be where it's turning, so negative 2, negative 7. And then our vertical asymptote is y equals negative 3. Our domain would be, the max to the left it goes is negative 3, and it goes positive infinity. And then the range for every single logarithmic equation, the range will always be negative infinity, positive infinity. Okay. So let's go on to our third and final equation. Okay. For this equation, it would be y equals 9 minus log 3 minus 2 minus x. Okay, this would be our third equation. Right here we see, growth, logarithmic equation. Okay, but here you see that we have reflection across the x axis, and right here reflection across the y axis. Okay, those two are very important because that will change our graph. Now, meaning that we have a reflection, we will start at negative 1 0. Okay, and then for this, it's a growth, or it's negative 2 minus x. For this, you should always know whenever it's minus x, it's going to go the same way it goes, so left 2. That's just a little small hint that I use whenever you see this, because what this really means, it just means x minus 2, and then you have to distribute it. Scratch that, just keep it at this, left 2, and then this positive 9, up 9. Okay, so for this we would go left 2 because that's right here, left 2 would be at negative 3, and then up 9, keep right here under the thing. Okay, so we would be at negative 3 9. Okay, but for this equation you have to keep in mind that it's a reflection, so this is the normal one, so reflection across the y-axis would look like that, and then reflection across the x-axis would make it look like that, so we have to put that. Alright, we have to find our vertical asymptote, which would be left 2. Left 2 would be right here. Hopefully you can still see this. Our transformation point right here, okay? Vertical asymptote at y equals negative 2. And we have to make it look like that. So it would go down and then turn right here and start going. So this is our line. Right here. And then we start going this way. Okay. So our transformational point for this one is at -3, 9, because we started at -1 to -3. And then our vertical asymptote, y equals -2. Our domain, this one's going max to -infinity, parentheses, and then it's going to max is -3. But on these vertical asymptotes, you have to know that for this line, you always put, for dotted lines, you always put a parentheses, because it keeps on going. And then the range, always -infinity, +infinity for all logarithmic equations.